Hello, Thomas.
Hello, Marcin. How are you today?
Looks what I have. I have Jason Mason's car.
Oh, great, great. I heard that one of the customers had a very interesting meeting with one of the workshop
guy, and the workshop guy has problem with him, and he has problem with the car and with the workshop guy.
Well, sometimes it happens.
Yes, it happens.
Yes. Sometimes the workshops, the guys that are working in the workshops, they have some idea in their mind.
Imagination in relation to the settings of the car and how it should work on alternative fuel.
That's right, that's right. So this is the topic of today's meeting. We would like to present you some basic but very important things about the calibration, about the errors, mistakes that that the workshop can make.
So let's call it like a main issues. Yes,
right.
That we are receiving last few weeks from our workshops on our customers. Yes, the phones or emails.
That's right. That's right. Thank you very much for all the information by the site, right? When we can find in our email on Facebook and YouTube.
Okay, so let's start from the first issue, and the first issue is related with the ignition switch or the RPM signals.
No, we can start one or another RPM signal, right?
They are related to. These are the main signals that they are deciding to initiate the gas ECU to work. Yes, first is the RPM source signal. And second is the ignition.
That's right, that's right. And when we are talking about the RPM signal, we need to mention that depend of the type of the ECU, the STAG gas controller, you need to connect the RPM source. For example, we are talking about 400 dpi.
Yes, this is like a mandatory signal.
Mandatory, right? Or if we are talking about the Q generation, Q family controllers, in this situation you can connect the RPM signal using crankshaft, camshaft or the coil signal, or you can use the pulses of the petrol injectors. Just like in the STAG 200 Go Fast ECU.
Yes, and take the consideration on Go Fast. Yes, the Go Fast today version is free of the wire signal. There will be additional wire meanwhile created that in the hardware in the Go Fast ECU that some cars they have problems with reading the properly RPM signals from the petrol injectors, like today in Go Fast. That's why we'll add it.
So you're talking about the secrets.
Yes, I am. And the rest of the MPI ECUs they have the version of the connection. Yes, you need or you don't need to connect. Depends on the type of the car it is. So what we will do, we'll start engine now, start the airflow, that will exhaust from outside the workshop. So let's do it, and then we'll connect the computer with the car and the engine, and we'll show you some examples of this. So Thomas, start the airflow, I will start the engine.
Yes, and so we started with the source of RPM. As you can see in the engine parameters, you have access to the some of the options, when one of the options is source of the RPM. Our controller has the possibility to connect to one of the three sources: camshaft, ignition coil, and petrol injection pulses. Okay.
Exactly.
What we need to do, what the workshop need to do? Workshop need to compare the RPM value represented here in the right side of the software, when you have the name of RPM, and we need to compare this value with the value on the dashboard, inside of the car,
the RPM,
right, or we can use the window with OBD reader if controller is connected to OBD.
Of course.
Okay.
Then show how to turn it on the RPM speed. We can choose it on the list. Yes,
right. If you don't have the RPM on the list, you need to press that button.
Configuration, yes, configuration button.
That's right. Here you have the RPM, engine RPM.
Yes,
you need to select this, exit, and then you have the readings of the RPM in the OBD window. As you can see, when you look at the software, the RPM is now right now we have 0, but in the OBD reader we have the value that is in the OBD, right?
Around 800 now.
800 now. So you need to set the camshaft, the source of the RPM. Okay, we have the camshaft. Maybe
if it's camshaft and there is no RPM, we should set the RPM signal voltage threshold.
That's right. First, the voltage threshold. We change the voltage threshold depending on the type of the camshaft sensor. Usually it's around 2.5 volts.
Yeah.
This threshold is okay, but especially with the Japanese cars, right?
This is the case of the Halotron. It's like 90% of the sensors are halotronic sensors. But as Thomas said, there is some Japanese cars like Toyota and Honda when they're using the inductive sensors, and this kind of inductive sensors, they are having a different threshold reading, around 7.5 or 9 even volts. Then the RPM reading should appear properly.
That's right. But as you can see, we changed the values from 2.5 up to 7.6 volts, and there is no RPM signal. So maybe the RPM signal is connected to the ignition coil, right? So when we change to ignition coil, as you can see, once again, we have 0.
Exactly.
Yes, so by changing the voltage.
And this is a similar situation like in a camshaft. We should choose voltage threshold. If it doesn't working, it means that maybe the steering is different than EC. You cannot realize that. And of course, the last it's when the wire is not connected. We should choose petrol timings.
Right, that's right. So let's check with the petrol injection pulses. Okay, and as you can see, we have the RPM signal right now in the software, on the right side of the monitor window, and we have the RPM signal in the OBD reader. We can compare those two signals. They are similar, so that means we correctly choose the source of the RPM, right?
Exactly. I want to another two factors. There is a minimum pulse time and the RPM filter. In case of very low petrol timings and issue with the readings of RPM, we can lower down the value or going up, depends on, and RPM signal filter in case the readings are unstable. As you see here is around say 700 and is stable. If this one will be variable, you can tune it on the filter to reduce these distortions. Yes, that's the way what we can do.
Okay, so Marcin, now we have the RPM signal selected, right? We have the readings of the RPM, so we can pass to the next issue that the workshop can find out. It's the problem with the ignition switch.
Ignition key signal.
Yes.
This is very crucial to indicate the working of ECU. The ignition signal should be connected to the voltage that is disappearing after disconnection and is appearing immediately after ignition on. Yes, in position on the ignition on, then should be 12 volts. It's comparative to battery voltage.
Battery voltage, that's right.
It should be voltage. It means that if you are using a kind of probe, using a LED light or just there is a not multimeter, and you are not sure that it's a 5, 6 or 12 volts. Sometimes this kind of probe it's not equal to the reality. That's the better way is to use the multimeter. Yes, and using the multimeter and measuring the real voltage is giving us the real information about the and this signal is value or it's wrong value in this case.
So just like Marcin said, when we have the proper signal selected, we can connect our brown wire to not brown wire, sorry, brown is about the RPM source, but red-black wire to that wire that we have the 12 volts or according to the battery of the car. If it's a good connection, okay, we can check it in the inside of the car, looking at the switch petrol gas.
Yes, exactly. So let's show how it's working properly, and when the switch goes not properly.
That's right. That's right. Okay, I will change something in the installation. Let's set to have the simulation of the bad connection of the ignition switch wire.
So as you see, the system is starting working on LPG. Now the system goes to the fuel, and then if we turn off the engine, yes, as you see, the light is still blinking, the RPM is missing, but the ignition signal is still holding on the voltage. It means that we connected improperly. The voltage is not disappearing, and then can occur some issues. I will restart the engine. Thomas will fix it. Okay, then you can look at the behavior of the LED switch. We are again working on the LPG now. If I will turn off the engine, watch the LED, it's turned off. That it should work like. It means that we properly connected the ignition switch wire, yes, like this. And Thomas, let it back. And what are the others issue with the ignition switch is properly or improperly connected? Yes, the fuel emulators, the pressure.
That's right, that's right. It's very important if you need to use our fuel level emulator or fuel pressure emulator, right? FLA or FPA emulator.
Boiled in the QMAX or QBox.
Oh, yes. QBox, yes, depend of the ECU. It's very important to have the good readings of the ignition switch, because if you want to use our emulator, but the connection to the ignition switch is not correctly made, right? The emulator will not work, or they can have
make
the distortions.
Yes. On petrol fuel level gauge.
That's right.
Readings.
Or the fuel pressure sensor, right? If you are talking about the QMAX controller. And the last thing that you said, Marcin, about the LED switch, right? You need to remember that sometimes the problem that the customer can call you with this problem is that the battery is
yes,
discharged.
We can occur the drain the battery. Yes, if the system is not tuning on properly, ignition switch is disappearing, but the voltage is still there. It can occur battery drain. So after some short period of time, 2 or 3 weeks, the ECU will just drain battery. That's all. That's why in this case we can destroy the battery.
That's right. So, Marcin, we have the RPM signal correctly connected. We have the ignition switch correctly connected.
So what we can do, we can start the
auto calibration.
Yes. And after auto calibration, because auto calibration is the process when we forcing the ECU to analyze the petrol data, yes, and the gas data, and so on, the conditions during idle, yes, and
that's right.
After idle.
After idle. Okay, when you start the auto calibration, just like Marcin mentioned, auto calibration is working only on idle. Okay, the gas controller is checking the real pressure that is in the pressure sensor, the real temperature of the gas, and some injection matters, injection things connected with the petrol injectors. But all the data that gas control is gathering on the idle, right? Exactly. On the idle. So after auto calibration, you need to check what is happening with the mixture when the engine is working in the, let's say,
middle conditions, full load conditions.
That's right.
And
that's
then
right.
Also in the open loop conditions, when the petrol ECU is working on without the control of the lambda sensor. Yes, it's not checking the mixture. In this case, there is a dangerous area when we can very shortly destroy the components of the engine if the mixture is too lean, and this is a crucial. So auto calibration is just the first step. There should be another 2 steps of the control of the gas dosage, middle conditions and the full load conditions.
Yes, it's the first mistake that we can find in the adjustment of the system, right? When the workshop is finishing the work after auto calibration. So what we need to do is to start auto calibration, of course, but then check how the engine is working with the middle and the full load conditions.
Yeah, and the next topic is related with this. It means that control. What does it mean, control? So the next topic is the mixture.
The proper mixture.
The lean or to reach. What does it mean and how to control? So after the 2002, all the European cars and also in the Asia markets and in the North and the South of America, there is a regulation that the cars need to have an OBD. OBD to control. And in this case, we can use it to connect the QNX QBox Plus and QMax Plus with OBD. And we can read very important 2 factors that we can use it doing mixture control. And these factors are short trim fuel trim as the STFT and the long time fuel trim. Yes, these 2 factors are giving us an information about the mixture.
And it is very important to understand how to use those factors. First of all, you need to check how the engine is working on petrol, right? You connect the ECU with the OBD on the board diagnostic and check that STFT and LTFT when the engine is running on petrol. It's let's say 90%, 95% situation. We have the OBD readings around 0, right?
Okay, let's talk about this, showing the practical.
That's right.
I will again start the engine.
We have connection,
and
right?
We want to show you the screen now. Okay, let's see the screen.
Okay, so start the engine.
Okay, so if you see our application, watch the OBD reader window when there is some information taken from the petrol ECU. The engine is now working on the petrol, and as you can see, the shortly value, it's a percentage value. It's a correction of the petrol opening of the injector timings. Yes, it means that the these two corrections, short trim and long trim, together they are creating the summary correction of the petrol dosage.
And what does minus means? Here we have with the minus, and here with the positive and negative value.
We can see the effect of the mixture. If the mixture goes too lean, it means that the petrol ECU will extend this value. It means if you want to add some more fuel,
that's right,
this value goes up. It means that it will be plus 5, plus 10 or more. In case of the mixture is going to reach, as you can see now, is minus 2, minus 3. This value is very low. Yes? If it goes more than 10, it means that the mixture goes much more to reach.
That's right.
Case, yeah?
So with the negative, we have mixture to reach. With positive value, we have mixture to lean, right?
Exactly. And what to do now? So after auto calibration, let's check what is happening now. So we'll turn on the gas, then please observe the correction data and the reaction for the multiplier. So as you see now, it's going very close to the petrol behavior.
Right.
So it's nothing to do now. What I can do, I can simulate the mixture will be to reach. So I'm going up with the multiplier. And the reaction is that, see what is happening with the short trim is going up, minus 5, minus 6, minus 7, minus 8, 10, 11, so on. It means that we have to reach mixer. We need to lower down the multiplier line to reach the value close to the petrol value. It was around minus 3, minus 5, nothing more. Still is 10, it means that it still is to reach. So I am lowering down the multiplier line and observe the reaction of the short trim and the long trim corrections. If you are too lazy, sometimes it's happening that these corrections are going to fine after some time, because some of the petrol ECU, they are starting remembering this value, reset this value, and the additional factor that we cannot see here, like there will be a long trim but it's a hidden value, then the problem will be that we'll switch the fuels, we can occur very improper engine working, yes, because ECU adapt himself to the working of this to reach or to lean mixture and remembers the value in a hidden data. We can occur errors during switching the fuels, yes, some errors or misfires or other issues. That's why during the calibration of the multiplier line, we should switch constantly petrol for a few seconds, then again CNG or LPG fuel.
That's right.
Watch the reaction. If goes minus, we need to reduce the multiplier point, yes. If the point of regulation is here, so we need to drive with the blue line goes here. So we need to put the load, hold a little bit in this area, watch the reaction, switch the fuels and observe the reactions. We should do this in the few points. As you see here, there is a line that we are working on the petrol timings. It goes from 3 to 11, maybe 12, yes, because this is a limit for this car. So we should put 2 or 3 points of regulation and make it during driving.
That's right, and we can slightly move to that lines that you mentioned, right? The blue line represents the petrol injection timing, let's say, and the green line is representing the gas injection. And in the old system, or with the ECU that doesn't have connection to OBD, sometimes the workshop, the technician are trying to set the installation using those blue and green line. Please remember, in the new cars, new models, you need to set the proper mixture with more precise, let's say. So using only the blue and the green line, you cannot achieve that, because when you look at the blue and the green line, you can only make some primer adjustment, let's say. Just only check if its mixture is not too much too lean or too rich. But to be more precise, you need to look at those factors STFT and LTFT. So not only blue and green line, but using the OBD correction.
Yes, and at the end of the regulation you can use auto adaptation, but don't forget, don't do this after auto calibration, but after the base settings of the multiplier line.
Right.
Then you can use it auto adaptation. Auto adaptation will help to improve the variability of the many conditions. Yes, if the temperature goes up or down with gas pressure will change, or the gas temperature will fall down a little bit, or go high a little more, or even much higher. Auto adaptation will help you to automatically reading these corrections, correct the gas dosage. And
That's
here we have some data, like this is our target OBD, and this is the map when the petrol ECU summary correction, for an example, is close to 0. So we can leave here 0. This is our target, yes, 0. If you will see that the petrol ECU strategy on this engine will be summary higher than 0, it will be minus, means like minus 10 or plus 10.
Yes, the
so it will be different than 0, yes, not higher, it means that different than 0. We should add some values here, depends on behavior of the petrol ECU.
Or you can use it, make this adjustment automatically by selecting
Using,
collect OBD.
Collector. But don't forget to turn it off after the petrol drive.
That's
so
right.
you can drive the petrol using the collection option. Drive the petrol on many different loads. It will be written automatically here, and then you can turn it off the map, but do not forget to turn off the collection.
Yes, that's right.
This is the temperature of engine when we are starting using auto adaptation. This is the adaptation threshold, that the summary correction, the difference between gas and the petrol will be higher than 3, adaptation start to work. And this is the place when adaptation stop to work. Maximum limitation of the, it's 25, you can use it 25, there is no such a big issue if you set 25. Correction reduction, this is a kind of medicine in case of sick correction, let's call it. So what is the sick correction and which one is the normal one? Yes.
Yeah, normally when you connect the OBD to the cars and you're looking at the STFT and LTFT correction, they are working in the range, let's say, starting from minus 30% up to plus 30%, yes. Okay? If the correction are working in this area, that means in our language that is okay. Normal, that they're okay. But there are some ECUs, petrol ECUs like Manetti Marelli, yes. The Italian.
They are using just extension of these values. They can
right.
rise up even to 100%.
That's right. So you need to use the correction reduction to reduce the readings of the
reducing of the readings, not the reducing of the corrections.
That's
just
right.
The reading.
Just the reading. That's right.
And as we said, this is a collection of target. Then we have inverted in case of mixture goes to reach, but we have the plus value here. Yes, it means that we have inverted SFT. There is a very, very rare situation when you can meet these conditions in some. Also, the Italian and the French cars. 1% of the cars have inverted corrections. It's very rare.
That's right. You can check this, for example, changing the multiplier line, right? When you are moving the up multiplier line, that means that you are increasing the injection of the gas. And when you look at the OBD and the OBD, it goes to
short goes
positive.
plus.
Yes,
It means that they are inverted.
they're
corrections are
inverted.
inverted.
That's right. That's right. That's right.
Last thing about auto adaptation is auto adaptation in open loop conditions. This helps to correct the gas dosage if petrol ECU will show you the lambda value during driving on gas will be lean. If you choose it, it will help. But we do not recommend to use this option automatically because the system cannot predict some strange behaviors. So better is to just check the lambda on petrol, check the lambda on CNG on LPG, and then correct it using multiplier. It's much more better and safe solution than using auto adaptation in oil. This is for very lazy but people, but you can just over fuel the engine. Yes, so there will be losing 1 or 2 liters the gas using this option. Yes, if customer is very strict on the fuel consumption, please do not use it.
Yes,
do it manually.
Yes, our recommendation is to manually check the mixture on the open loop condition, the status of the engine. And 2 last things about the auto adaptation. If you want to check what the adaptation is doing or what the changes that auto adaptation made, you need to go to the map correction B1 or B2 if you have the engine with 2 banks. Okay, and on this map you can check the values. You can
this is the end effect of the adaptation.
Of the adaptation. So parts
this is
of the
like a kind of the map, like petrol is remembering this long trim on his memory. This is what the gas ECU is remembering during the driving. Here he needs reduce the gas dosage 6% to handle 0-0.
That's right.
Close to 0. Or here, in these conditions, the ECU should add a little bit more gas, 14 or 50%, to reach the 0-0 on petrol.
That's right.
Corrections.
So this map is very good equipment to just
diagnose if everything is okay.
Yes, or check very fast which part of the engine you have with the more lean mixture or more rich mixture.
Exactly.
And the last thing, just remember, if you have the engine with V6 or V8 engine, that they have 2 banks.
Yes, if you go to the auto adaptation, crucial is here.
Yes, to go to the gas controller settings, then change the gas injector settings, and if you have connection to the VQMAX controller that controls 6 or 8 injectors, you need to connect, check the assign, let's say, assign the bank.
And where we can find it, it is here. Watch this, bank 1, bank 2, and the injectors, gas injectors. We need to set properly localization of the gas injectors in case, like in the example, injector number 1, gas injector is on bank 1. If it's on 2, you need to choose bank 2.
Bank 2. That's
and
right.
so on. The next all injectors is 6 or 8 injectors. The assignation is very important in these cases if you want to use adaptation, because without this auto adaptation will correct all the bank what is happening on the first, it will do on the second.
On the second, that's right.
So
that's right.
It can occur that you can see on the first effect. It will be that we will having different timings on banks. This is the effect when sometimes the workshop guy is asking why after some mileage the car is having extension and little bit different, or even sometimes 50% different timings on one bank comparing to second bank. And then if we open it, the window, and see that the assignment is
not made
or just fixed
incorrectly,
properly set it, yes, and so it needs to be fixed. Then after fix the issue of assignment, we need to recalibrate everything again, because Petrol ECU also is adapting himself, yes, for this data. And the next steps we can follow.
Yes, the next step. So as I'm looking at our notes, according to the adjustment of the system, we said everything, all the issues that the workshops can find out, but the last thing is about the injectors,
settings.
gas injectors, right?
Yeah. As you see, this is a list of the injectors with the support of ECU. And the issue is if the customer, the workshop guy, is having the injectors out of the list and he's asking how to set the system. So the main factor is to know the construction of the injector. It means that the body of the injector is the full metal or is a plastic metal, and the coil resistance of the injector, single injector. If you know this data, you can choose the similar construction from the list, but for sure we should use injectors from the list.
From the list, that's right, because it's very important, because if you have the injectors on our list, that means that we know the characteristic,
yes, the characteristic of temperature characteristic
and the pressure,
the steering characteristic, pressure characteristic, flow characteristic. Yes, it's important to reach out the proper gas dosage. Yes, in case because all the gas injectors, they are also steering not saturated, but they are the pick and hold, like direct injection engines, petrol engines. When the injectors are pick and hold steered, when the peak current and the hold current is very important to have stability of the injector opening time and closing time. So if you choose proper characteristic, we are sure that the gas dosage and the overall engine working will be proper. In case that we can use the injectors out of the list, we are not 100% sure about these parameters.
That's right.
In this case, there can be some issues with the cold or overheated injector, with some misfires, with some jerks, etc. Issues related to this.
Okay, Marcin, so I think all the issues that we heard about.
Yes, this was the last few weeks information taken from you, from emails, from some calls from the workshops. So of course, if you can have some more questions or more quotes or issues that you can you want to share with us, and we want to share with you some explanations and solutions, please write an email using the address stag@stag.pl. Please contact using YouTube channel or our profile on the Facebook. Yes, do not hesitate. We will answer, we will help, or we will follow to the next webinar with these topics for you.
That's right. So thank you very much. Thank you very much for watching. I hope it was interesting.
Yeah.
Meeting. So
take care. Be healthy. See you next time.
see you. Bye.